trigonometric identity that I want to prove is another compound angle formula. So it's cos A plus B is equal to cos A cos B minus sin A sin B. So in order to prove this, I'm going to be using a formula that is a different proof in itself. So it's the formula 4 of the trigonometric identity proofs. So I'm going to be using this proof here. So it's another proof that is also on the course. So I'm going to be using this as a given. So cos A minus B is equal to cos A cos B plus sin A sin B. So I'm starting off with that. And there's a separate proof for this here. And now using this, I'm going to be replacing angle B with minus B. So instead, I'm going to replace B with minus B. And we know that if we have cos of minus B is equal to cos of B, but sin of minus B is equal to sin minus sin B. And that is to do with our unit circle. So if we have a unit circle, if we're going this way, the angle is going to be positive, but if we're starting here and going this way, the angle is going to be negative. So here we have cos is positive, all of the angles are all of the ratios are positive. Here sin is positive, and here tan is positive. So if I have a positive cosine angle here, and then I have my same angle down here, it's still going to be positive because cos and all my ratios are positive here. But if I have a positive sine angle and then I go to a negative angle, my sine is going to be negative. So then I'm just going to replace B with minus B. So cos of A, so minus B. So replacing into this formula here is equal to cos A cos minus B plus sin A sin minus B. And then I'm going to simplify this. So we have cos, so minus B is going to be plus B, and knowing that cos of minus B is equal to just cos B, so cos A cos B, but sin of minus B is equal to minus sin B, minus sin A sin B, and that is our formula proven. So the main thing to remember is we have this formula given to us in our log tables, but to remember that if we have, so in this quadrant, cos is positive, here sin, cos and tan are positive, here sine is positive, and here tan is positive. So if we have, here we're going to have positive angles, negative angle. So if we have a positive angle, if we have the cos of a positive angle and the cos of a negative angle, they're going to be the same because cos is positive here and cos is positive in both these two quadrants. But if we have the sine of an angle and then we get the cos of that negative angle, if we get the sine of that negative angle, well, here only cos is positive, so the sine is going to be negative. And that is our identity proven.